Good evening, everyone. I am Dr. Abrar Khalak, your 5-day workshop trainer. Welcome to day 4 of our Civil 3D workshop. In the last session, we learned how to create surface, import the data, and prepare our base model. Today, we are moving into the core of highway design, where we actually start designing the road. Today, our focus will be alignment tools, profile creation, assembly creation, corridor modeling. I give you a short introduction about the baselines and regions, and then we shift to the cross sections views. So today is very important because this is where design start becoming visible. So before going on the first part of alignment, yesterday we faced some difficulties in importing the corner points, and also what we do if our surface is not no fit. If there is some elevation issue, how we can solve it. So due to a hectic schedule and loads of age, we have a 2 hour of a long workshop. So and we have to cover so many things. So we left these two things. So I start with them, and then we in speedily we go for the alignment. By not wasting so much time, let's just concentrate here. So what we do before importing the point, let's create 2 point group. The first point group is all points is the civil 3D itself take. So I will give a name like 1, 2, and 3. So in this point group, I am importing all points, and then again I create a new group. I will give a name as you know uh, corner. Okay, and I am giving some different style here. Let's give it here elevation and description. And in our second point group, I change the label style as description only, so you understand what is the changes here. So let's import our point first. See, as you repeatedly use these things, so you will never face difficulty while you importing all the things while you working in. So we select our point style, all okay. Now we have a group. I create 1, 2, 3 group for all points. So I select 1, 2, 3 and then give okay. So now my all point is inserted. Then for showing the point, I set Z enter, E enter. And I scale it as low as I can, 150. Okay, now it's all right. Now again I'm importing the point. See, if another point, the surveyor team gives you the another point after marking on the location, then how we import them. So again I select the same point style, and I set this point in our point corner group and set okay. Yes. So see, I set a benchmark as a point style, and as a label style I set elevation and sorry point number and description. So this one is different. We set as a corner point, and this one is our previous point. We give a style as only description. Now the second thing, let's again do this. I will show you the surface now. Let's again import point. Now this time we are not creating a new group. We just import our point. See, again I set our point file format, and this time I am not doing anything. I'm just open that points, and I show that point with the help of Z enter, E enter. Okay, done. Now let's create our surface first. I give the surface name as anything A, B, C, and I'm not doing changes in here, as I want to show you the uh, if you stuck here while you are working, then what you can do to solve your problem. So in point group, I can add that all points, apply and OK. See, our surface is generated. Now to see this surface in a 3D view, I have to select this surface and go in object viewer. In object viewer, I can see my surface well, but when I shift this surface here, I can see there is something no good, no surface is not creating well here. So when you are importing your point and you create the surface, and at that time, if you find that your surface is not proper and a peak point is there, so what it means is our surface has elevation. All the points have their own elevation. So if any of your point have a zero elevation, then it will stuck to the ground and your whole surface go upward to the elevation points. If some point have a low elevation, then also this problem happens. So when you are working on a real project, this type of problem is not avoidable. So we must have to work on this. So let's quickly see what we can do here. We can edit this surface. How we can edit? Tomorrow we see this. After selecting this surface, we can go in a edit surface. But when we select the modify point, they ask us you must have the surface point displayed for this operation. So what they want to say, we select a surface style here. See, in a point group, I go in a property. Uh, we have the point style here. We can go in our point style in a display option. Our marker label is okay. Then we can go here like in a description only, and we again edit this in a drag style summary. Done. So all the things is created properly. Okay, that's okay. Now see, this is our point. So first, what I do, uh, I have to check our surface. What is the elevation of our surface. So first of all, I select here. I can select the add label. If I select the surface, uh, in this contextual tab, there is a one option named label and tables. So we can check the surface label from here. If you want to check the elevation, you can check your elevation from here. Uh, so let you can put the point here and you can check the elevation. See, it has an elevation of 40. It has an elevation of 40, elevation of 58, elevation of 58, elevation of 50, 46. So the point we have making the difference, we have some elevations issue, like we have 58 and it has a 46 and still the elevation is going down. So to solve this, what we do, okay, let's select the surface first, and then we go in a surface property, and we give a style contour and triangle, and apply this. So contour and triangle is here. Now they are asking for the point label. So what we can do, we can edit this style. We edit this option, and here in display, see, our points is off. It is not visible. So I have to click on and make the point visible, and then click apply and OK. Then again apply and OK. Now see, my all surface style point is also visible now. Now how can we set our elevation here? we select our surface, we go in edit surface. Now you know how to add the line, how to delete the line. This is the region lower surface. If you want to put your whole surface at some, you want to give raise at 5 meter, so you select this and give the plus 5 meter, your whole surface go up 5 meter. And if you give the minus 5 meter, whole surface go down 5 meter. So this whole thing we covered yesterday. So now I just want to focus on this point. If I select this modify point, so what happened, it will ask me select your option. So previously when we select this option, they asked us to set our surface style as a point is not visible. So now what we do, see this red marker is our point style, and this marker is our surface style, surface point. So I can select at any point. We can select at any point and select enter. So as I see, the elevation is 38 here, and we have throughout 58 to 60 70 elevation. So I will give the elevation here 58. Now the new elevation is created here. Same again, I will check this point, this, and say enter. See, it has a 58 elevation. This is not a problem. Okay. Then again we check the third one, because we face the issues here. So I check this 3 point. I select this point again and select enter. So it has also 58 elevation. So now all that 3 points have the 58 elevation. Now I select my surface again and go to the object viewer. See, now after setting all that elevation at one level, now you can see there is no point who is going outward of this surface. So now your surface is very smooth and clear. Now you can go ahead with your surface. So these two things I want to clear first. So now all set here. Uh, let's click. Let's again change the style. Uh, First we have to select the surface. Go in a surface properties, and then in a marker style, I again select apply. Okay, apply. Okay. Now today we start with the alignment. So first we start with alignment, which as you know, the alignment which is represent the center line of the road. In Civil 3D, alignment defines the horizontal geometry. And as per you know that what is the horizontal geometry design, what is the what it include in horizontal geometry. So it include tangents, curves, spirals, all that things are included in horizontal geometry. So with the help of the alignment tool, we can create our road with the help of the center line. Then we work on that center line and create our proper road. So in our alignment tool, we have a line, curve, and spiral, three things. A line we denoted as a tangent, curve we denoted as a simple curve, and spiral is a transition curve. So remember these definitions, these denotations. Line is a tangent. So whenever you see the tangent point, you have to understand that this is our line. When you see the simple curve, it is curve, and when you see the transition curve, it means it is a spiral one. Okay. So alignment is like the skeleton of the road. Everything working after this, it is only on depend on the road alignment. So now I will create an alignment using the layout tools and apply curve as per the design standards. So now what we do, let's first clean our surface. So whatever I can do here, you can understand properly. So let's change our style, surface style. We put is as a border only. Apply. Okay. Now we have a point group. Okay. In a point, see. Now in a point group I have one point group named all points. So we go in properties and set this basic as a none, and apply and okay. So now our surface is very clear. So let's start with the alignment. Here in a create design panel, you can see the alignment option here. And in a civil 3D, whenever you put your cursor on anyone, it will show you what it is for. So when I select here, it provide the command for the creating alignment. So when I click on this, I can see so many things. With the help of I can create a new alignment. See, the first one, alignment creation tool. So this is the tool. If we don't have anything, we can create alignment with the help of this tool. So today, the alignment creation tool is the one we work mostly on this. The second thing is create alignment from object. So this is the second thing. If we have one object as a polyline, so we can directly convert that polyline into the alignment with the help of this alignment creation tool. Then create a best fit alignment. As a beginner, when you are practicing, you explore this option when you are practice today or tomorrow. What this is option about? When you click on the option, they will ask you uh, uh, how you want to create the alignment, by clicking on the screen or by clicking on the cocoa points. So if you are saying by clicking on the screen, then you click on the screen and automatically they create the alignment which is best fit. Then we can create the alignment from the corridor. With this option we can create the alignment for the pipe networks, pressure networks. If we have an existing alignment and in that existing alignment we have to create a new alignment, we can choose this option. Then this two important thing which is we use mostly, alignment offset and connected alignments, and then the road widening. Okay, so let's quickly go with alignment creation tool. When I click on the alignment creation tool, one pop-up is one layout is open here. So first I have to put the name of this alignment. If you are not putting any name in the alignment, then what happen here? See, they give you a name alignment and there is something in bracket. So what is this? If you click on this option, so it is a number style 1, 2, 3. Your number is starting from 1 and at increment of 1. If you select the alignment, if you select this tool first time, it will automatically take alignment number 1, and then you set okay, and then when you create the second number of alignment, the next counter will be taken automatically. The alignment itself gives alignment number 2. So if you are not putting any name here, or civil 3D automatically give the name. But what we do, we give a name alignment number 1. Okay, now we have types: center line, offset, curve return, rail, and miscellaneous. So this miscellaneous is used for different type of networks, but right now we are using the center line alignment, because mostly we are using the center line alignment. As we have a center line, we can do anything with them. We can add the offset, we can add the uh, extra width if we want to provide. Then here you show the description. In description you can provide that this is the area where you work on, or whatever you want to show here. Then the station range here, as we are not creating anything, so station is 0 plus 0 0 0. Then we have 2 points here: general and design criteria. See, in a general, uh, the site is not useful here. When we create these parcels, then it work with the help of the site. So site is not we not doing anything with the site. Then alignment style, as we have a point style, surface style, the same way we have alignment style. So different style is there. So I am selecting the proposed style. You can select any one of these. Then alignment layer. So as we already know what is the layer, so we are not doing anything here. And at last, the alignment label set. See, all labels there is a different type of label. In no label you cannot see anything. All label they provide you all type of label, major and minor, and all these things. So whatever you want to do, you want to select from here only. If you want select this label, then in the same alignment you cannot modify. Then after if you want to add the label, you can add the label. So what I do, I want to make you understand that how to create a label if you forgot, or if you want to give another label after working. So I am selecting here no label. The second thing is here design criteria. As we all know that design criteria is very important for creating our road. So here you can see two things in a design criteria. The first one is criteria based design, and the second thing is design check set. See here, using the design check set. Okay, what is the difference between these two? Criteria based design, this is a complete design rule system used while creating your road. It automatically control all the things like minimum curve radius, maximum speed, super elevation, SSD, vertical curve length, K value. Civil 3D use the standards like IRC, ASTHO, RTA for Kenya, KENHA. So this is the different countries code. So Civil 3D use these codes and design the road correctly from the starting point. If you select the criteria based design, okay. For example, if you select the design speed is 80 kilometer, so Civil 3D will automatically suggest proper curve radius, super elevation, all the things as per this design speed. So criteria based design is designing with rules. So you have to understand this first concept. And second, use design check set. Now when you are coming here, you have to understand if you want to work with this option, or only this, or only this option. So now design check set, this is used to check whether you already created design is correct or not. So it does not design anything, but it only gives warning like your curved radius is too small, side distance is not safe, your grade is too steep. So if you manually draw a curve and you set the design check, this curve does not meet minimum radius. So they will give you a pop-up like that. But it does not mean they are not you are not working further in it if you set the design check set, because design check set is set for our purpose only. If we are doing something and if we want that while working on this alignment, I have to clear that my radius is not going from 300 or from 200 meter. So when you go 201, and if you selected this design check set, it will give you a pop-up that you are going beyond 200 meter. So design check set is checking against the rule. That's only. Okay. Now let's if we are in alignment, let's talk about the design also. See, what is this design about? If I choose the 80 kilometer per hour speed, and Civil 3D automatically gives us some codes. So we have 2011 code, 2080 code, road design 2004. So it all based on the ASTHO standard. And as I previously talked that ASTHO is our green book. So in every country code there is some difference, but not too much within the ASTHO code. But it is still our priority that we have to check all the codes where we are working on. So you have to select any code from here, and whatever the code you select, you can check here. I select the ASTO 2011 metric E maximum 4%. The transition lane table is a 2-lane road, and a crown road method is used for this 4% of elevation method of this code. Okay, what I do, I'm
Hello,
not hello.
sir. One doubt is there. Can I import our design criteria file like that one is in?
uh, I I will
Can
go there. I will go there. So once let me finish once so all the part of this design, then your doubt will automatically clear. Don't worry about it. Uh,
Okay, sir. Thank you.
okay, dear. Okay. So right now, what I do, I'm not selecting anything. I'm just going in a flow. I set okay here. So as I said okay here, here I see one pop up, and this is a tool where I can design my road with the help of this all the tabs. See, understanding this all tab is very important. But before we are going deeper into this, what I can do, I will first complete the design topic. So all that things before starting the project. So you can control your design check set from here also for here in alignment in a design check set. So you can if you have a line code, you can edit this code from here. You can if you want to add the length, if you want to add anything in from the line, you can add it from here, and you provide your own value here and save that code and use that code also. This is the one method. So you go for anything like for the line, for the curves, okay, for the spiral. So this is the one path. And if you are not want to do here the work, and if you want to set your own, then you can set your own like if I want to means see k value, I want to set the k value as per my criteria. So I what I can do, I can set minimum radius or a minimum spiral length. So what is the best fit option for this k value? So length is best fit. So whenever we create the curve, so based on the length of that curve, the k value depends, the k value change. So we set the length, and we can put any criteria like less or equal or greater or equal, and we add this here. So this will also set. And if you in design check set, if you click on the design check set and create a new, then you can set your new folder. Like I set my 123 folder, and whatever the design check set I created here, I can add that. If I create in a curve, then I select the curve. And if I create we are not create that k value, but when if we create the k value and select okay, the k value show here, so we can select the k value and add this. So this type if we select okay, so our new folder is set here. So this is the first step. But this step is used when we work on a smaller area, and we have to change only small values. The second thing you can do, you can type the design check set, design design criteria editor. Okay, as you open this, as we selected the 2011 code of ASTO. So what is the value given in ASTO? You can see here. See all the units, which unit value they are using for the line, area, volume, and speed they provided here. In alignment, all the things are here. If you don't know, sometime what happen, it is not a problem that you are not knowing the things. Because you are not knowing the things, that's a little problem. But when you go through it, you will be knowing everything. uh, if you find any code, and if you don't know what I have to check from this code, so this is the work you can do. You can open this design criteria editor. You can go in a unit, you can go in alignment. So when you click on a plus icon on alignment, you can see in alignment what is the thing included. So this minimum radius, super elevation, these things are included in alignment. Then minimum radius table, there are different type of codes for the different super elevation percentage. So for 4%, they give the design speed, like they give the design speed 15 for the radius of 4 and all that things. So if you are creating the road for the 80 kilometer of speed, so you have to check first that we have to put the radius is 280. not far from 280. And there is a manual calculation method also. If you have the design speed and if you have the radius, you can calculate the radius is fit for the design speed or not. For that, there are so many equations. We are not going deeper on that manual calculation. I want to show how to check what is the design check set, how you, whenever you working here, how you check that what is your minimum criteria of for this design speed or for this design speed or for this design speed. You see, now this is the one thing. The second thing I want to show you, let's go internet. So see, this is one code I open on the internet. So the codes are available whenever you search anything. Like if you want the code for the horizontal curve design, you can search it, you can find that code. See, uh, minimum radius for horizontal curve of different terrain for the terrain area. This is plain terrain, ground area. For every particular area, uh, we have the design speed and the radius we are provided here. So this is the one of the code I use, I taken from internet. So purpose of showing you this code is how to whenever you see a code, how to see the code. So in a super elevation, you can check all the theories. What is the super elevation? How they calculate the super elevation? Yes, what is um, the super elevation? The variation of curve they provided. What is the details of all the things as per the speeds and as per the radius. So all the things they provide here. If for the design speed, if the radius increases for the 4%, 3%, 2.5%, what is the difference in the super elevation values? So see, this thing, we have a different design speed and we have a different percentage in a super elevation. The same thing you can hear in our civil 3D. We have a different percentage and every different percent for we have a design speed and we have a different radius for each design speed. See, so this type also you can see all the things. If you uh, uh, if you want to add some new design code set and you want to use that code set, so you can add that code set from outside to your civil 3D also. The method is same as I want to show you the different code. Yes, see, say we have a different type of roads, and for all that different type of road, we have a different design speed. So for the three type of terrain, mostly we have, and for that terrain, what the value we can consider. So before, this all the things are a prior work. See, the submit curves, how the submit curve works. So this all things I will provide you this all the code set, but you have to make sure that you use the the latest code, because these codes are I searching just I'm searching on internet and click open whatever I first saw. But you are not doing this thing because we are learning, so I can just go through it. I want to show only whatever I have to check in a design code check set. But when you open the code, you have to find the latest code and you have to open the latest code. You go through only through the latest code only, because if you go through the different codes and some values you keep in your mind, and when you are go for the interviews or when you meet someone who is good in the design, and in your conversation you are right, because you go through the codes. But if you say the old values, then it will make a bad impression. So this is the second thing you have to take care. Now let's again go our alignment creation tool. So alignment number one, the center line, uh, the site and all the things. Here I select the no labels. Then we go in a design criteria. So as I select this design criteria, so as per this design value, whatever I have a mistake, they will show me. But right now I am not taking this because I have to. We have to understand the flow. The one thing, the question arises that if we can use our own code or not. So yes, you can use and you can set your code from here. If you open this and if you have any file like I have, see, I have one two design code somewhere in my folder. So as you know set your design code set here anywhere in your folder, you can select it and you can use it here. But make sure that your design code is in XML file. So it is mandatory to use XML file here to upload in Civil 3D. So the file type is very important. So every time I mark your attention that you must have to know all the file types wherever it required. See, I close this and I set is okay. Now let's go with these tools. The first one is if you have only the straight line, you can select this and you can click only straight line. If you set the curve here, so there is no smoothness in curve and it will show you some problems when you select the design criteria. So it is not a good practice. uh, if you have want to provide a curve, then you must have to select the tangent with curve. If you have some setting, like if you have like I want to take this length and I want this type of radius in my alignment, so you can choose any method from here and you can set your code and set okay. Then whatever the things you use, like if I use this, so as I set this criteria first, so my all the work based on that criteria only. See, now I used the second option and I do the same thing. See the difference. Here I can Civil 3D not provided me any smoother curve, but here they provide me the curve. Why? There is a tangent no curve method and tangent with curve method. In starting, I will tell you whenever you show the tangent, you must have to click in the mind that tangent is a line. Okay, so if you have a curve, you must have to select this tangent with curve method. Now, if I created these things, and the second thing, this is the PI points. If I select any line and I understand that this is not our proper line. This PI point is not there. This will be straight. So if I uh, select a one PI point here, so it will take the alignment edge per my PI point. See, if I select here, it will set the alignment edge per my PI point. If I select the delete PI, so whatever the PI I select, it delete automatically. See, now my alignment is straight. Then the another thing you have to know about this line, there is so multi option here. You can use a fixed line. If you have a two, you want to connect the 2 points, then you can choose this fixed line. If I select here and I select the 2 points, I can get one alignment here. See, I am working this all the things in alignment number one. So when I select one, all the alignment selected. So make sure if you are creating the first alignment, so you have to create that alignment, and then if you are working on the second alignment, then you have to start the process from the beginning. You have to give the name as a second alignment, and in that second alignment you have to provide your second alignment. If you just give the alignment number one and you give all that alignment from your alignment only. See, if I want to give my alignment from here, so what I have to do, I have to click on the shift button and right click button So here they give us an option that you can choose the end point, you can choose the midpoint, you can choose the intersection point. So for accuracy, we using this. If I use the midpoint, so what is the it directed to me to the midpoint, so I can create this. See, now this is also, this all are also in the alignment number 1. See, check here, alignment number 1. Okay. Then there is a fixed line from curve end length. So as we have a curve, and from the end of the curve I have to put the any length, so I can put it from here. This is the fixed line base fit. So what is this? See, as you select the best fit alignment, they uh, show you that you have to put the input options. See, give you 4 options from cogo points. You know what is the cogo points. If you want to create the alignment based on the cogo point, you can select it. If you have any entity, you want to create the base fit alignment in on any entity, you can select this. If you have any AutoCAD point, if you imported a AutoCAD file here, and on that particular file you want to create the alignment, you can select it here by clicking on the screen. So if I select this and say okay, so see this mid ordinate tolerance, as we previously checked this, for the accuracy you can provide this. Okay, now as I select on the screen some points, see 1, 2, 3, 4, 5, and select enter, and then one pop-up is open and I have to say okay. See, this is the base fit alignment they created by itself. As same we have curve options here, the same way we use this fixed line options, the same way we have the fixed curve base fit 3-point curve. If we select this, we have to provide the 3.1, 2, and 3. So when we if we have a side point, and on that center line, existing center line point, we are going to create our existing alignment, and we don't have any idea that what is the best fit curve here. So you can use from option from this curve tab, and this is the free curve base fit. So you can you know select the any two entity and provide the curve, because we don't have that type of entity. So the second important thing I want to show you here is this. So this is the delete sub entity. If uh, you make this alignment, if you want to delete this, so you can click it, it will automatically delete it. Then the next thing, this. So what is this? When you select any alignment and you go here, so it will show you uh, whatever the type you use. You use the parameter of 2 points. What is the length? What is the direction? What is the starting station? What is the ending station? So you can check it from this panorama window. Then we have this sub entity editor. In this sub entity editor, you can edit all your values from here. As we are not starting our work, it is shown blank. But when we starting our actual alignment, all the values are shown. We can change the parameter of that alignment from the here. And this is the elevation editor. When we create our one alignment, it will shown. So I hope you understand this alignment layout tool. Now the second thing in alignment, create alignment from the object. So for that we have one object, like I create one object by with the help of the polyline PL enter, and I create one polyline here. See, I create one polyline here. Now if I choose this option, create alignment from the object, uh, they told me that select the first line, or any polyline or any arc or X reference line. If you imported any file, you can select this line and say enter. So now they ask you the direction, the flow of your alignment is in this direction, or you have to reverse the direction. If you want to reverse the direction, you click here, and if the direction is okay, you directly select the enter. If I want to change, I say reverse, so your direction is changed. See, now again the same process as we create alignment before, the same process. If I uncheck this curve option, so what happens? The curve is not created properly. But if I select this option and set OK, so automatically the curve is created. See, the next thing, create offset alignment. So this all the things we draw is a center line. Okay. Now, if I want to draw an offset of any offset here near the center line, what I do, I go here from the create offset element. I select this offset. Okay, now they ask me uh, which is the alignment you want to work. That alignment number one, from starting to end, I have to give this station range. If you have any template, as I previously said, every company has the template. You can import the template. So if you have template, you can choose that it from here. Number of offset on left side. So this is our left side and this is our right side. So on a left side, I need one offset, and a right side also one offset. If you don't need any offset right side, you can put it 0. But yes, I need both side. And what is the increment you need? So I need 3 meter. Then I'm not doing anything here. Then the widening criteria. So if you want to give widening at any particular point of your road, you can provide here. If you select OK, all the things on, and if you OK, the automatically uh, at every 1 meter, after 1 meter of width will be there, and whole your transition length 20 meter of length, they will give you the widening. And this is the offset profile. So right now we are not in the profile option, so we are not using the profile right now. We are keep in a general and say OK. So as I say OK, it will create me an offset both side 3 meter. So now my total road is 6 meter. This is the center line, and from the center line this is 3 meter and this is 3 meter. So this is how we create the offset. Now again, see, we have this two road here. We have some intersection here. So what I do, I provide offset here. So I want to understand you the connected alignment. So this is the basic how we create the connected alignment. So when we create the offset alignment and we select this option and we select OK, uh, because we are in a one entity, so it is not taking. So let's create a road number 2. Let's create the polyline. I select the polyline from C, PL, enter, and I specify that I want a midpoint. So this is the polyline I created. See, now this is a polyline, not alignment. What I do, I convert it into the alignment. Create alignment from the object. Select this. Say enter. Yes, direction is okay. Now I'm not doing any changes here. Say okay. See, now this is my alignment. Name alignment number 1, and this is my second alignment, alignment number 2. Now this is 2 alignment, and this 2 is totally different. If I select this one, the all alignment is selected, which is we created based on the alignment number 1. And if we select the second number of alignment, this is the only alignment we create in the alignment number 2. Now again, we provide the offset here in alignment number 2. We keep it as the same. Yes, now I want to show you the connected alignment. So what is the work of this connected alignment? See, I will open it here. so you can see it properly. When I select the connected alignment, they ask me to select the first alignment. As I select this as a first alignment and this as a second alignment, and they ask me the location. I want this location, so I click on this location and select the enter. As I select the enter, it will show me the same menu. I have to give the name, description, your connection from which alignment to which alignment, it is shown here. So if you want the criteria base, you can select the criteria here. If you have any parameter, so yes, I have parameter. So what I do, is whatever we have, as it is, I select and do the preview. See, in our curve group type, we select the circular fillet as the this is the best fit option here. You can select any of style you want to choose. So now I give the preview, so it will redirect me, create the connected alignment, yes. So unable to create the alignment because of the current location in a curve group type. See, we select the curve and let's reduce our curve, and again we set a preview here. Let's select curve 10. We have to select another curve style. It will, I think there is some problem. Not a problem, we delete all this thing. Again we go for it. Let's create two alignment with the help of polyline. Let's create one polyline here. Okay, and let's again clear the polyline, and we select the any of the point. Midpoint. PL enter midpoint, and we can say a second alignment here. So see, now we create our alignment from the object. Select alignment number 1, set direction. This all okay. We don't have to erase the entity. All thing is set. Now okay, this is our alignment number 1. Then again we create alignment from with the help of this. Done. We don't provide any curve here. Done. Then we go for the offset for this alignment. All right, then again we create the offset for the second alignment. Select it and okay here. Then we go for the connected alignment. Select the alignment number 1, select the alignment number 2, select the direction and say enter. And then we set all the things with no labels, so you can see all the things properly. So here let's select the curve fillet and give the radius of 30 and set preview. Unable to create an auto fit connected alignment at the current location, please select another curve group type and this offset value. Okay, so here something we have a problem in offset. So don't worry, when we are working on the intersection tomorrow, I will show you, because this is the connected alignment is best fit for the intersection. When you create your intersection and when you have to give that proper corridor on that intersection, then first of all we have to create this. Why this problem arise? Because of the elevation point. See, as this alignment have their own elevation, and for the second alignment, is this alignment have their own intersection, elevation. When this both alignment connected at one point, at one here, so first we have to check that the elevation of this point and elevation of this point, they are same. If they are not same, then this type of problem happen. If they are not same, we have some options to set that alignment. But when we are in a profile, so there is a one option named composed profile. When you compose the profile, then what happen? The profile of this alignment and profile of this alignment, they connected with each other, and then we provide the intersection point, and then this connected alignment works. So don't worry about this right now. I hope you understand the alignment properly. So what I do, we create one alignment, and based on that alignment, we go for the profile view. So we create one alignment through the alignment creation tool, and we gave the name is road 1, road number 1. Type center line with no labels. Design criteria, we are not using any design criteria. Okay. So with the help of this tangent curve, I select the point from here and put our alignment here. See, we create this one alignment. This is our starting point of curve. This is our ending point of curve, and this is our tangent. Okay, and this is our curve with the radius. Right now we are not showing anything here, but don't worry. As we are, understanding the labeling now. See, once this alignment created, what we do, we give the label. See, once we create the alignment. Hello,
Hello.
hello. Ah, yes.
One quick question, actually, if you don't mind, can you recreate this alignment once again if it doesn't take much time? Because something is
Ah,
lost
no
here.
problem,
I
no
don't know what
problem,
happened.
no problem, no problem. See, I again go
And also,
alignment
when
creation
you
tool.
access the commands, no, please do it little slowly because of the internet, it is not the menu is not completely shown. So I'm able to only see that you're clicking once it's coming to the screen, and I'm not able to see which tool you are selecting. So give some at least a second or 2 second gap
Okay,
so that I can see. No, we can see
okay,
all those tools available. I think there is a lag in the internet. Thank
okay.
you.
I will take care. Yes. See, we again give the road alignment name as a one. If we set a same it is, and if we set a no label, so you we go through with no label what we saw. If we set all label here and say okay, as we say okay, we have this layout tools. In this layout tool, we open the first option here and select the tangent with curve. As we select this, we click here, we set our alignment. Okay, as we set our, if you want to end this, you can set escape or enter. So your alignment created with all the details. See, this is our major station. 0. The first station we starting from here is this is 0. This is the right side, left side, as 0 is here. So this one is our left side and this one is our right side. This is our station 0 plus 0 0. Our design speed is 100 kilometer. So we have an interval of 20. So every 20 meter they set a major station, and every 10 meter they set a minor station. So minor station they denoted as only tick mark, and major station tick mark with the value. Okay, now you can see here in a curve. So in a curve you can see the first point PC, the starting of curve, the midpoint, and the end point. Then our again tangent start, and this is the end of our alignment, and the last station 0 plus 418. So 400 meter of road we created right now. So this is the first step if you want your label with your alignment. Now I will show you the second step. I close this. So once you create, you can close that pop-up bar. Now if you want to reopen that pop-up bar, what you do, you select the alignment and you select here geometry editor. As you select your the same thing come again. Now we go again create alignment. uh, I set as a road 2 and then I select here no labels. See as no label and say okay. Again I go with the same things. I create one another alignment here with the cows. See I again create one alignment here. So this time we not have any labels here. So how we can put our label? We have to select the alignment. As we select the alignment, you can see, as you select your alignment, you can see add labels here. See, if you want to add a station label, you can select the station label. So first of all, I add the major station, and we have a option, different option, parallel with thick, perpendicular with line only, perpendicular with thick only, and the different style also there. If you insert the template, you can edit this. You can create your new also. What I do after selecting the major station, I put add button. So as I select the add button, you can see your major station at 20 meter of interval. Now I don't want a 20 meter of interval, I want a 10 meter of interval here, and I say apply. As I say apply, you see every 20 meter we have a interval of major station. Now I can add a minor station too, but minor station I can click only apply only tick and then add. We have to insert this minor station here. So as we inserted the minor station, it will automatically take the minor increment. As we have a major station at every 10 meter of interval, then it will take automatically the minor station. Now I again click apply. So you can see every 5 meter we see the tick mark. If you want to add geometry points, so you can add your geometry points also. If you select the add button, the pop-up is here. I don't want to see all that things because if I inserted all that things, our alignment will be messy, and if we send a messy alignment to anyone, it will not create a good impression. So what I do, I don't want this. The important points only I'll show here. Rest of the thing I close, I uncheck it, and then I said okay. So your geometry point is also added. I apply it. So as I apply and do okay, see this is all the set automatically created when you choose all the label. And when you don't have any label, so I show you how to add label manually. See this is all the major labels at every 10 meter of interval. This is all minor ticks at every 5 meter of interval, and this is the curve tangent we added, starting point, ending point, and the starting point here. See, okay. Now what happened? There is so many labels here. So if you want a single segment, like if you uh, want to show some segment to the surveyor team, so you have to click on the single segment button, and what it say, you have to select a point or entity. So I select this entity. See what is the radius of this curve, what is the length of this curve, what is the tangent point. So all the things they show here. If I select this here, it will give a single segment like our northing point, easting point, and the elevation point. So again, I click on the alignment. I select the alignment. I go on the add to label. If I want to select the multi segment, so with the help of this multi segment, I can, you know, again and again I can click anywhere. If I select the multi segment, so on every part they provide a segment. Okay. Now the next label style. See, now we have add alignment labels. See, if I if you want to give a table to your alignment, uh, whenever you provide your alignment to engineer or a client or a surveyor, so make sure that your alignment is very smooth and very decent looking decent. So what happened, uh, and with that decent work we have to provide all that points. So how it is possible? So we can create a table also. So near our alignment we can put that table, so the contractor or the client can check the table and understand the alignment behavior. So for that we have to go add label and add alignment label. When you select the alignment label feature, you set as alignment, and you set a single segment or multiple segment. If I say single segment, so what happened actually, the alignment is created based on two things, line and curves, as I previously told to you. So they we have to give the number. So our line label style, see, we have a different style here. You can select any style from here. Whatever the style you want to set, you can choose here. If you say add click button and you select the entity, the same thing, the add segment you provided before, the same thing you provided from here. If you go for the station offset fixed value, you can see the label style. Again, you can click the add button. You can select the entity. So now, what you do, we select the perpendicular. So at any point, we can set these things. So this is what you can select this, and you can manage this thing from here. You can put it here also. You use this mark, this square marks, and put it this anywhere. See, this is what, if you mark some point, like if you want the description of some point on the location, so you have to add this point here on your alignment. So and you can export that point with the alignment. So whenever the surveyor got your this alignment, they understand that where on a live location where they have to mark. So we provide this type of point to them with the help of the station offset. Then we have the multiple segment, single segment, point of intersection, can't point, station offset, and all that things we saw here. See, when we go for the line and curve, if you want to know the line and curve, you can select the if you want to be select the bearing and distance. For the curve you want to show the grade, then add this here, click on the alignment. So all that things you can show here. It will be messy, I will provide everything here, but don't worry. Then the next thing is you select your alignment, and if you want to provide tables, so you can provide a line table, you can provide the curve table, you can provide all segment. If you select here at the add segment, so it will show you whatever you have. So the style is here, which alignment you want to show. This is the table style they create automatically. Make sure you are selected the mode dynamic. as you doing difference anything in alignment, the table automatically make it update. And as you click on the OK and you put it here, so your table is created. We don't have any value because we are not selecting the table value of radius, length, and anything. Because when you select the alignment and you want to put the label, so for that what you have to do, when you go add alignment labels or at a station label or anywhere, so from here you have to set some things. Like if you are here and you change the criteria, you see here layout, you can see as a feature points, you can see as a feature point. When you set a take button here, when you set a take button here, only that time, when you set a take button here, only that type, all that table will created automatically. Okay, so now this is all for the alignment. Now what I do, I delete this all things, and now we go for the profile view. See, now what we do, we create alignment again. We give the alignment as a road 1. Okay, and set all the things, and major and minor station only we select the label style, and okay. Tangent with curve. Why I'm doing this again and again? Because as you see again and again the same process, you understand how we going for this. See, this is our first alignment. Now what I do, I create a second alignment, road number 2. See, Civil 3D, make your work continuous. As for the first alignment, I select the label. For second, also whatever you use previously, they take automatically. Set is okay. Again, I go with the tangent with curves, and again I create one alignment from here, and I will also provide some curves here to understand these things properly. See, now we have two alignments. Okay. So this is the option profile view. So what is the profile view? Actually, profile view is a, once alignment is ready, the next step is the profile, and the profile view represent the vertical alignment of the road. So two types of profile views there. The first one is existing profile, which is our surface profile, and the second one is design profile, which is our finished road profile, which we know as a FRL. So first, what we have to do, we have to create the surface profile from the existing surface, and then once the existing surface profile created, then we put a design profile there. Now the two important concept, the first one is grading and the second one is vertical curves. So grading is a slope basically, and if I am talking about the vertical curves, there are two type of curves. The first one is a crest curve and second one is a sag curve. So I go through very fast all this topic because understanding these things is very important before creating the alignment. So what is gradient? Gradient means how much the road is going up or down. In a simple word, it is the steepness of the road. For example, if a road rises 2 meter in 100 meters, the gradient is 2%. Make sure the gradient is always in percentage. Whenever you saw a grade, it is in a percentage. It means that every 100 meter of length, elevation changes by 2 meter. So it is denoted by 2% of gradient. So there is two type of gradient, positive and negative. Positive always go upward and negative always go downward. So understand these things. Then we go for the vertical curves. So there is a two type of vertical curve, crest and sag. When two different gradient meets, we provide a smooth curve. See, instead of shape change. So this make a smooth connection. We can call the vertical curve. So what is a crest curve in a simplest way? I try to explain this both in a simplest way. When the road goes up first and then go down, then what happen on a top? On a top we have a curve, and we know that curve is a crest curve. Make sure the one thing, on a crest curve there is always one problem of visibility. You can't see vehicle ahead clearly on the top surface, because the crest curve is starting from the bottom and then go up and then go down. It is in a inverse U shape, not a U shape, inverse U. Then the second one is a sag curve. Sag curve is in a U shape. So this is different. In a crest curve, we go first upward. Here in a sag curve, first we go down and then up. So the curve create the downside, and it is in a U shape. So in a profile, we also manage this both curve and gradient. Okay. I hope I clear these three things to you. Now let's quick go to the profile view. So for creating a profile view, what we can do, we can select here in a profile and section view table, and we select the profile view from here. Also create a profile view from here also. Again, if you click on your alignment number 1, you can see a surface profile and profile view here also. This is the second step. And the third step, when you go here in your prospector tab and go in your alignment, in alignment we have a center line alignment. We have a road 1. If we click on the road 1, there is a profile view. As we create a profile view here, you can change or edit the profile view from here also. So this is the 3 way you can operate your profile view. Let's go quick with the one easiest way. You can select your road and go for the surface profile first. See, we are working for the road 1. So before the creating this, you must understand what is your road. So when you put your cursor here, it will show you the name road 1, and if you put your cursor here, it will show you the name road 2. So we are on a road 1, so we select the surface profile here. We can click the surface profile. As we click, we can see this tab here. See, as alignment is a road 1, if you want to select the, if you have a lots of alignment, you have not remember the alignment name, you can click here and you can select that alignment also from here. Okay. Now we have a surface name ABC. See, and if you are not knowing that your what is your surface, you can select it and you can select your surface from here also. Okay. Then you have to add this surface. As you add this surface, you can see all that things that this is a dynamic. Make sure this is dynamic. The style, the station, all that things it is created. Whatever the station it will take with it, it is also shown here. Then we go for the draw in profile view. If you select OK after this process, then again you be blank. Where this thing go? So again, operate this thing. What you have to do, you just have to click on a profile view. Then see here, the first one is general. In a general, select the alignment as a road one. Then you can give your profile view name as we have a profile for the road one. We can set a name as a profile road one. Then description, then the style, whatever the style you want, you can give, and then set as a next. Then you come here in a station range. What if you want to set your range automatically? So it will take a whole length. If you want to specify some range, you can click here and set the range from here. But I want a whole the range, so I keep it and select as a next. After this, we have a profile view height. This is taken automatically as per your elevation. If you want to give height, if you want to modify the height, you can select the specified and put the height here. This is the style. You can edit all the things from here also. Then we go next. See, if you have too many profiles and you want to show only one profile, so you can check or uncheck here. Make sure the your profile is dynamic. So as you update your road, your profile update automatically, and all the style and all the labels that are shown. Which then we go for the next. If you have a pipe or pressure network, then you can also add that network from here. But right now we don't have. Then we go for the data band set. So this is the bands Civil 3D automatically gives us. If you have your own bands, you can import it here. This is the location, the band location. Our band is shown below the profile. If you want top of the profile, you can set it. Now we again click on a next button. This is the cut area and fill area. This is the H option. But for the H option, we need two profile. Right now we have only existing profile, so we cannot hatch it. So now we create a profile view. As we create the profile, okay, it will command us select profile view origin. So if I want to put your profile view here, I can click only here. So you can see our road one profile is created. The below you can see it is a band. Now let's understand this profile first, and then we go for the design profile and for road 2 profile a little fast. See, this is your vertical profile of your road. As you see your road here and you show this surface, here you check the two things. The first thing, this is the grid view, and this is the existing ground profile, EG profile. So we set a name as a road 1 profile only. So when you click, put the marker on this red one, you can see your surface 1 profile. See, now below is your band set. You when you select your profile, when you select your profile view, you can see two things here. The first one is profile view properties, and the second thing is profile properties. When you see here, the red line is your profile, and this box is your profile view. So if you want to edit this profile view, after clicking selecting this profile view, you can go here in a profile view property only. If you want to edit a profile, this red one, you can select this profile property. As I select the profile property, it will ask me to select the profile. I select the profile and press enter. As my profile is shown, this is my ABC surface 1 profile. I can give style from here, any style you can choose. The profile data I can also, and if you want to set the design check criteria, design check set, also you can set the design check set criteria from here also. Okay, so this is about your ground profile. Then after selecting this, we go for the profile view property. So in profile view property, you see here the information. So our profile is road 1 profile. If you want to change the name, so you can say uh, EG road 1 profile, or profile of road 1 EG existing ground level. So you can change the name from here also. In station you can change the station if you want. Elevation also you can set your elevation. The profile view. So how we create the things, if we want to change anything after creating it, you can change. The most important thing is bend. Now see this. Now see, this is the bend. Bend is what? Bend is showing you all the data which is we are working here in our grid view. So here there is one automatically one bend created whenever you create the profile, but I don't need this bend. I select this line and click this red button and click apply. So my bend is gone. Now I want to create my own bend. So what I do, I bend type, I select the profile data, then I go here, I need elevation and station, and I select add here. If you want to edit this, you can edit this from the here band style and all that things. If you want to create your new band, you can create your new band from by editing this thing. We add this. They ask this thing are available here. You can check or uncheck. I want all the things. Then I select the OK button. So now I have a elevation station here. So see here, we have the style here. We have the gap from the profile. The first band gap is 12.15. Then the major station, minor station. You can change your major and minor station by double click it. As I undo the process, and what I do now, I create a design profile first, so you can understand betterly this profile view. Let's select the profile, and for the design profile for proposed a new road, we have to select here in a profile creation tool. As we create a profile creation tool, we can set this for our new profile. So here I type that this is my road 1 design profile view. Design profile is you want to provide the complete label set, you can provide from here. If you forget to provide the label set after selecting that line, here you can see your labels. You can see the label is now not visible, but when you select your design profile, the label is visible. You can add the label from here also. Now you can set the design check set criteria also. You put it OK here. Now the again the same menu open as we saw while the alignment creation tool. So what we do here, we create a design profile by maintaining our grading, our curves, and cut and fill. So what we do, we start our design profile when where our existing profile is starting. We click the first point here, and then we go by clicking. See, I maintaining the things, so cut and filling is not come. So this is my top area. See, now I go for this one. Then I go here. Then I go here. Then I click here. Then there is one cow is preparing here, and then I select the last point here. See, as I know where is my, see, as we select all codes, so that's why this will be a messy one. uh, I set my scale so you can see it properly. See here, you can see the three things, uh, two things. The red one is your ground profile and the blue one is your design profile. As you can see here the label set, you can see the your first point, your second point, your elevation, station, your k value for all the pi point that I selected. The second most important thing is gradient. See, there is one criteria. You have to set your gradient between +3 and -3. This is a minimum range. Sometime it will people will go to 5, +5 or -5. More than +5 gradient and more than -5 gradient we avoid every time. As low your gradient is, as your cutting and filling and your road is manageable. See, I will show you my all gradient. So we have this first pi points, and you see your first, our first gradient is 1.65. The second gradient here is 1.23. Then the next gradient we have here is -2.24 because we are going in a downward direction. See, this one is -5.70. It is -5.7. Sometime what happen, it will take 2.6. If you want to change this, you can change. You can change this gradient. I will show you how to play with this profile view. See, now if I select this, you can see so many grid point here. This is a circular grip. This is a triangular grip. There is one diamond grip also. See, now I want to show you that how this grip works. See, when you select this grip and you want to adjust your curve, you can select this round grip and you can manage your curve with the help of this round grip. See, so if you select this round grip, it will only minimize or maximize your radius. Okay. Now, if you, so for this round grip, there is one round grip here. If you select this round one, you can set your gradient. You can manage your gradient from here also. See the line, see the changes. The second thing, for this curve, if I select this one, you can minimize or maximize your curve. But the next first entity where we selected and the second entity where we end, these 2 point remain fixed. Only our curve is manageable with this triangular grid. Okay. And when you select this grid, you can manage the line from with respect to the next entity. So this is the grip you have to understand. Then there is a last some grips. You can manage this road with the help of this grid. So now let's understand the profile view. Let's make our profile view better, we select the profile view, uh, and we select the profile view. We go for a profile view properties, and let's talk about the bands again. See what I do. I select this existing band and delete it. I create my new band. First I add elevation and station, and then add this. Okay. Here you can see the band type, elevation style, gap, major, minor station. If you want the first and end station, you click here. If you unclick it, your first and end station will not shown. Then this is our two profile. See, we have two things, elevation and station. What I want that our profile one is be surface profile and profile two will be a design profile. So we can check both elevation and stations. Then I set apply and OK. See, now we can see the elevation and station. See, the station is simple, same for everyone. Now you can see the two station. This one is for a ground profile and this one is for a design profile. See here. Okay. Now again I select it. I go for the profile properties. Now what I do? Uh, let's I zoom this. So whatever I apply, you can see the difference here. I go for the profile view. I put the profile view here. Now you check this thing. Yeah. Now here you can see the things. Now I set. Now I want to set the horizontal geometry, and from here, from the bend style, I take the geometry and add this thing and apply. So as I apply the geometry, you can see our geometry is added. See, then I add the vertical geometry, the same geometry I add this and apply. The vertical geometry is done. Then what I do, I go in a profile data from the bend style. Then I go for the cut and fill value. So first of all, I set the cut data and then add it. Okay. Then again, I go for the fill data and add it. Okay. Now, in a cut and fill data, last two row, I have to change something here. See, I want to show the cutting. So for cutting, what I have to see that I want to show that the profile one is my existing profile and profile two will be my road one profile. So they uh, differentiate my existing profile from the design profile. So if they match these two profile, then our cut will explode. If the same two both profile are same cut profile, then we are not seeing anything in a cut profile. The same I what I do intentionally I set this same and set the show the difference. I set apply and OK. See, now we have our station and all that things, horizontal geometry, vertical geometry, cut and fill data. So here in a cut data you can see there is no cut here. See, you can see 0.03, the red color mention our cut area, but in a fill area you can see only 0.000 because we didn't provide any value. We provide the both surface same. What I do, I go again here and provide road one profile as a profile one, apply and OK. As I apply, you can see your fill area is also shown here. So this is your profile view. Now we can adjust this profile view. We can go here in a profile view. See, you can set your name here. You can put your style. In a station, you can set the station, elevation, profile, and bands, and last thing H. Now we have a two profile, so now we can cut and fill our profile. So make sure our both profile are selected in cut and both are selected in fill. Then we apply and OK to it. So as we apply and OK, you can see the difference here. Wherever cut and fill, it will mark with the hedge. See, the red hedge, it means we have to cut this, and the green area so that we have to fill the area. Again, I select the profile, I go in a profile properties, then I select the design profile and enter. See, profile criteria, design check set, profile logging, so all the things we can manage from here. The same as we select the profile view and go with the existing profile, the same thing you can set for the existing profile too. As we select the profile and go for the design criteria, so you can set your design criteria with the help of this. You can check also from here, you can add a new criteria from here, or you can import a new file from your computer also, and set that file as a design check set. So your profile is all set. Now uh, we explore this option also, this option also, this is also. Now there is two things, we have a edit profile view style. As we click on a profile view style, we can manage all that things from here. If I want a hedge, I want to clip the grid, so I can select this grid option. If you want to make changes in title bar, in style, text height, all that things, vertical axis, horizontal axis, tick marks, all that things you can manage from here. Now I apply and okay this. See, now your profile is in a best view. Okay, so what I do, I want to make the same profile for this alignment number 2. For that, what I do, I select the profile, I select this profile, I go again in a profile view property. Previously we set the band for this profile. What we can do here, we save this band, we set as a name as a day 4. Okay, and all band style is already set, so I say apply, okay, apply and okay. So what we do here, we save this band set. Now let's create the second profile. I select the profile, I select the surface profile, add the surface profile. See, alignment is road 2. Then go in a road 2 profile view. We set all this thing. We set the profile as a profile road 2 EG. Okay. Now we set all that things. Next, next. We don't have to change anything here. Next, next, and create a profile view. Now we create a profile view for the road 2 here. See, as we provide all the setting above, so it will automatically seen here. Here in this profile, what I did, I turn off the labels, so you can see our profile very neat and clean. If you want to add a label, you can select this and add the label from here. So you can add this, you can add all the labels from here also. Now again we select our profile, again we select our profile and go in a profile view properties. Sorry, we create a design profile for road 2. Here we put the name road 2 design profile. Okay, and I'm taking no label here, and then click OK. Then I create our design profile. See, make sure you have to select your profile, as there is no more cut and no more fill. You can select your design profile with the help of these tools. See, fix the tangent based fit. You can see set use this with this tool also. As I select these points, so it will automatically create me a best profile. I select one point here, then I again set this. I leave this area. I set this point from here. I just want to show how we use this. If I want to uh, best fit curve through the points, see free vertical curve base fit. I use this. Select the first entity and select the next entity by clicking on the screen. OK, and enter. OK, see the best fit curve is saved. As we leave this 2 point also. So this is the one way you can create, but right now I am just focusing on our traditional method for your understanding. So we go for the alignment number 2. Create OK.
Hello.
Only 2-3 minutes. Only 2-3 minutes.
Hello.
Yes.
Yeah, I have a quick question. See, we are already drawing the profile for road 2, but why are we again drawing on this manually? It should already come directly, right? I'm a bit confused here. So see, you are
Okay.
already drawing this
Okay.
profile for road number 2.
I will make you understand. I will make you understand. See, the red one is a surface profile. It is not
Okay.
a road profile.
Okay.
We add the surface in profile. Now we create a road profile, road design profile. See what happened. We create our one road on the surface.
Right. That's
Okay.
a road 2.
So for road 2. So
Yeah.
on this surface, where our road 2 is gone, because our surface is uneven right now.
Right.
Where we decide our road 2 on the surface profile, it will the profile view take that ground line here. Okay. So now this red line is the surface profile. As we first, before providing our profile view, first we add the surface in the profile.
Okay.
For the alignment 2, where our alignment 2 on the profile, they will take that part as a surface profile here. Now what we are doing as a design profile, we set a smoother road, because you see here this profile is created on the surface wherever we because we are not see while creating this road, we are not seeing any elevation, we are not seeing any contour. We just draw alignment.
Okay.
Maybe it will a high slope area, maybe it will a low area, maybe this one is hilly area, maybe. But while we design the road profile, so this is for the understanding that you can see our road 2 is starting here, and the starting part of road 2 is our 0 changes is here. See,
Right.
see, as we keep a curve here and finish our road 2 here, here in a surface we see all the things very good.
Right.
But
Correct.
this is the cross section view of the road 2. Now you see our first part is here. When we take a curve, so this is very down part,
Right.
and our where our road to start, it is very high surface. Here also there is a high surface. So we have to finishing this road by creating our design profile.
No, but are we doing this manually? Will Civil 3D not draft this? Help us draft how the road will go. We have to draw it manually in this elevation.
No, actually, what happens, sir? When you are working with the with companies or with your team, there is always one senior highway engineer over there. So they are creating what is the best area where we go with our design alignment, our design service. So first they provide a value here, like value number A, value number B,
Okay.
value number
Okay.
C, best fit value. Then
Alright.
they draw the profile.
Okay.
And they check what is the cutting and filling there.
Okay, the
And
profile what you're
and
seeing is a ground profile. I'm sorry to interrupt. The profile what you're seeing here on the
this is
screen,
a
this is
ground
a ground
profile for
profile.
road 2.
Okay, all right.
So sir, we check the name road 2
Right, right,
profile, and then we set EG, existing ground.
right,
As we set here, road 1 profile and name is EG.
right.
See, now I am creating the design profile, based fit profile. Now we think that this is the good road we can provide. So with this lecture, I will provide you one file, and in that file, I will work. I will show you how in a actual industry they will make these profiles.
Right.
Because if I, if I keep that file here and if I show you directly, you cannot understand all the workflow. Now you are understanding. See, now we created this design profile for our road 2 also. Now, see, once you create the road 1 profile, we do lots of things here. But once you did the things for the first profile, now you don't have to, waste so many time. As we set the band already, we select the profile. We go here in a profile view property. We import the band set. As we set as a day 4, okay. And now we just have to select this apply. Okay, see. And again for this view, see. I hope you understand. The first thing we do for the profile 1, automatically we set here for the profile 2. You can modify these all things as per your use, because every company has their own template. So for this also we have a different template. So here we have no cut or so the point is 0. We have a little fill. Then we can show this band set to our contractor, so they understand that we have this much of cutting area and this much of filling area. I hope till you all understand the things.
Yeah.
We can keep it here today.
Okay.
Tomorrow
And
we
yeah.
yes.
And maybe we can have once we finish this, you can further elaborate on this understanding the cut fill and how to identify them. So maybe once the class is done, or maybe sometime tomorrow, if you can add some more information on this, how to read this, because see, I am a mechanical engineer. Okay,
Okay.
so so understanding the roads and highways, it's a bit like for me a new learning. You have taught very well. There is no doubt in that. But still, I want to understand more about the profile. Maybe once if you finish the class tomorrow or before we start the class, you can just give us some.
Let's do one thing, because in a night time we all have a busy schedule,
Right.
and we have a very less time, so we cannot solve so many doubts.
Or
But
inshallah, maybe I'll contact you tomorrow. I'll ping you tomorrow,
if you
inshallah.
want to understand anything, you can contact me in a daytime.
All right, great. Thank you so much. Thank you so much.
No, not an issue. Not an issue.
Jazakallah
I am
khair.
here to teach you. Whenever you ask me, I already told you from the day 1.
All
You can
right.
ask me anytime.
All right.
Okay, so
Jazakallah.
we keep it till here. Tomorrow we are not going through all these things. You practice all day. If you have any doubt, kindly ask me the doubt in a whole day. Tomorrow we go for the assembly, corridor and cross section view, and then the seat creation. And the road design process we finish tomorrow. We finish this our 5 day of workshop. Even if there is something I want to tell you, if the civil 3D is so vast things, no one can teach you everything, because it is very broad. You see, when you open the alignment, in alignment there is a lots of option. In one option there is a lots of tools. So it is next to impossible that you understand all the things in a minimum time. But I will try my best. I teach you my best that whatever the things they are using on the field, you understand that flow. Now till then. So
Tomorrow
from
is the last.
tomorrow we directly go to the assemblies. How to create the assembly. I save this file and I give you this file too. And with this file, I give you the another file where we how we decide the road, how we decide the profile. So before creating this road and profile, we put a marker like A, B, C, D, E, F, 1, 2, 3. Here also, a simple 2D line, polyline, or what,
Okay.
or any drafting tools. So
Okay.
as per the highway senior highway designer engineer, if you have a highway design engineer, they give you a guideline that they give you a guideline on a pen and paper. Then draftman, what draftman did do they put it here in a file, and then they check all the criteria. If our design check set is allow us to do this radius or not, and all that things. Also, if you check my LinkedIn profile, I hope you all are following me on LinkedIn. If you check my LinkedIn profile, previously I solved some highway design problems manually and uploaded that video also. So if you understand this, what is the radius, what is the curvature, what is the spiral, what is the sec curve, so you can find the video also from there. And if you not find that much that type of video, uh, once in a week I create that design calculation manually and put the video on my LinkedIn profile. So you can follow me on LinkedIn too. So you will be updated. This is the field you have to connected and practice more and more. As you connected more and more, as you practice more and more, not a matter you are from the any field, you can do the work. And once you work on a real flow, one you finish the first project, second project, third project, then you don't have to put the number 1, 2, or 3. Then you don't have to set the feet base feet alignment or that things. As you see the profile, you understand I have to go from this direction. This is the best way. See, here you have to check one thing. See, we here we do a cut, here we do a fill, here we do a fill, here we do a cut. The same thing, the cut and fill ratio is very low here in my profile. So whenever you create your profile, make sure the cut and fill ratio is very low, because when you give this plan to the contractor and understand, assume that if your cut area is large and your fill area is low, I hope you understand by cut and fill. If there is the ground which is up and down, because the ground is up and down, we have to cut that part where we want to put our road in a actual situation. So when you give the cut area very much and the fill area very low, understand if the contractor cut the land in a actual site and your fill area is very low, so they
Right.
cut from one area, they put some soil in the fill area, and the rest of the soil they cut from the first area where he put it. This is the first condition. The second condition, in a cut and fill, if your cut area is less and your fill area is more, understand,
Yeah.
100 cubic meter they cut from the first step, and only 50 cubic meter is the fill area. Then they have to purchase the soil for a fill if your cut area is less, and the soil is very costly nowadays. And sometime road is preparing road is sometime in a desert area or in a remote area. So providing the material or taking the material from the city area to that area, it is also costly. So as a design engineer, as you design the things, so these two things is also very important. You have to take care while you create your design profile and uh, your ground profile. I hope till you understand all the criteria, because from tomorrow we are not going to show this again. So practice till all that things properly. And if you have any doubt, tomorrow you have a whole day. You can ask me, you can message me. I will solve you by texting. If the problem is critical, I will share you some short videos to understand you. So don't worry about anything. So bye bye everyone. Our goal is sharing is caring. So with this goal, I am taking your leave. Bye bye. Thank you. I am finishing the session. Shivam sir, you can close the recording. Thank you. Thank you for attending and understanding what I want to teach you. Thank you,
Tomorrow is the
everyone.
last session, I believe, right?
Yes, tomorrow is the last session, but world is not over. Don't worry about the last day, because you all are my student. After 5 days, also, if you want to understand some things, you can contact me. I am always there.
Thank you.
And also, if you are good in a practice, any of you are not sending me your practice, because you must have to send me a practice work. Without sending practice work, I will not provide you any certificate. So make sure whatever I practice, you create it on your style. You create the road whatever you like. You create a profile whatever you like. You will do a mistake. Kindly do a mistake. Do a lot of mistake. Ask me again and again. But keep practice. Practice till this profile view and share me your practice file with your name. Or you can share the practice file to the Shivam sir also. And put your file name as your actual name, so we can check all the things. So at the last, after the by tomorrow, whatever we teach, also you have to practice that thing also. And once we get the full practice of a particular student, then I provide the certificate. So make sure this thing too, because only learning is not enough. You must have to practice dual. I can give you 2.5 hour by speaking all this. I want to conclude all this lots of things by minimizing and by providing you the most important and easy way. So you must have to practice for make me happy. So this is my last request, and with that I am ending the session. Thank you so much. Taking your leave.